Today we are going to discuss actually laws of motion. We are going to discuss the main concepts that are going to be studied by us in laws of motion. Laws of motion, we have three laws, Newtonian laws. First law is the law of inertia that says that every body stays in a state of rest or in forward motion until it is disturbed by some external force. Then we discuss in the second, according to second law of motion, Newton's second law of motion, the net force acting on any body, the net driving force acting on any body is equal to the product of the mass of the body and the acceleration produced in that body. Now, if we have a system of connected bodies, then the net force acting on the system of the bodies is equal to the mass of the system of the bodies into the acceleration produced in the whole system. Because they are connected, so the acceleration that will be shown by this body will be the same as that shown by this body, because they are connected bodies. Now we are going to discuss this very case of pulley along with the friction, because the different forces that we study in laws of motion at 11th class level, those are gravitational force, weight, normal reaction, friction, tension, spring force, and these are the main forces that we discuss here. Now, in friction, we have got two types of friction. One is the kinetic friction, and second is the static friction. Kinetic friction is that friction which comes into play when the two bodies are in a relative motion with respect to each other. And static friction is that friction which comes into play when we are applying force on a body and the body is not moving. Why the body is not moving? Because the force that we are applying is negated, is neglected, or it is cancelled by the friction force. But that friction is occurring in the state of rest of the body. In the state of the rest of the body, that's why it's also known as static friction. The friction, whether it is kinetic friction or dynamic friction or static friction, it depends on the normal reaction. Now suppose we have this system of pulley in which the two bodies are connected over a pulley system, and this body is having mass m1 and this body is having mass m2, and we assume that m1 is larger than m2. So the body will be moving in this direction. When the body will be moving in this direction, we have to find the net acceleration of the system of bodies. How will we find that? We will find that simply by using the Newtonian laws of motion. The first law says that the body will be in state of rest in a particular direction if the net force acting on that body in that direction is zero. Now I am saying that the sum of the forces in this direction is zero. Why? Because it's not showing any motion in this direction. So the two forces that are acting on this body in this direction, n and m2g. So from the first law of motion, we can say that n is equal to m2g. Finish. That's what I said. And the net driving force acting on the system is equal to the m1g, because it is driving it downwards, and fk, it will be trying to hold it back because it's acting in the opposite direction of that of the motion. Now fk is mu kn, because I told you that the kinetic friction depends on the normal reaction, but n is equal to m2g, which I told you from the first law of motion we can obtain that. Then we can say that fk is equal to mu k m2g. So net driving force is equal to m1g minus fk. Instead of fk, we will write it mu k m2g. But according to second law of motion, net driving force is equal to ma. Ma is equal to m1g minus mu k m2g. So instead of m is the net force, m is the net mass of the system. So we have m1 plus m2 into a is equal to m1g minus mu k m2g. So a is equal to m1g minus mu k m2g divided by m1 plus m2. Then, so far as tension is concerned, the tension acting on the string, how can we find that? To obtain the tension acting on the string, we will take one body, say m1g. Now we will take the free body diagram of that m1g, of that m1 body. The force acting on m1 is m1g minus t, because m1g is acting downwards and t is acting upwards. So m1g minus t is equal to m1a, because the net force acting on any body is equal to the product of the mass of the body and acceleration. Now since we are separating this body, that's why here we will not use the mass as m1 plus m2, we will only use the mass m1. So we can say m1g minus m1a is equal to t, so t is equal to m1 bracket g minus a, and g, the value of a is same as that of this value. So we can substitute the value of a in this equation and we can obtain the value of tension. So this is how we can obtain the Newtonian laws of mechanics to obtain the unknown forces and unknown accelerations. So this is one of the cases in which we applied it. We will see you in the next case.